Here's two more derivative rules that, when combined with the power rule, allow us to take derivatives of lots and lots and lots of functions. The first rule is called the constant multiple rule, and it says if we have a function that's c times another function, then the derivative of f is c times the derivative of the other function. The second rule says the derivative of the sum of two functions is the sum of the derivatives. Let's see how these rules work. Let's look at the first rule and look at this example. In this case, we have f of x is 5 times x cubed. So we can think of x cubed as being this g of x. And we know the derivative of x cubed by using the power rule. So the new derivative is going to be 5 times the derivative of x cubed. The constant is 5. The derivative of x cubed is 3x squared. So we have 5 times 3x squared. When we multiply it out, we just get 15x squared. Let's look at the second rule. That says if we have the sum of two functions, like x to the fourth plus x to the eighth, the derivative we can compute by just taking the derivative of the first function. The derivative of x to the fourth is 4x cubed. And adding on the derivative of the second function. The derivative of x to the eighth is 8x to the seventh. So by combining these two rules, we can take the derivatives of lots of functions. For example, we could take the derivative of 3x squared plus 9x plus 2. This is the sum of three functions. Since the derivative of the sum of two functions is the sum of the derivatives, we can apply that repeatedly to apply to the sum of three functions. So we can take the derivative of each function separately. When we take the derivative of 3x squared, well, this is a constant times x squared, so we use the first rule. And so the derivative of 3x squared is just going to be 3 times 2x. When we take the derivative of 9 times x, well, this is a constant times x. And so if g of x is x, the derivative of g of x is 1. So it's 9 times 1. The last term is just a constant. We know the derivative of the constant is 0. So the derivative of 3x squared plus 9x plus 2 is 3 times 2x plus 9 times 1 plus 0, which of course is 6x plus 9. When you get good at these, you should be able to go from 3x squared plus 9x plus 2 to 6x plus 9 in one step. So by combining these two rules along with the power rule, we can take the derivative of any polynomial we want, plus all kinds of other functions that are sums of other functions that we know how to take derivatives of.